Right now, there is a rock the size of Africa hanging above your head, and it is slowly drifting away from you. Every single year, the moon moves about 1.5 inches farther from Earth. It has been doing this for 4.5 billion years. You will never notice it. But what if the opposite were happening? What if the moon were not drifting away, but falling toward you? What if, starting tonight, it began to spiral inward inch by inch, mile by mile, until it filled your entire sky, until the ground beneath you cracked open, until every ocean on the planet rose up and swallowed the land? What would actually happen if the moon crashed into Earth? Not in a movie, not in a thought experiment, but in your actual life starting right now. You would not know it at first. That is the terrifying part. For the first few days, almost nothing would seem different. The moon would still rise at night, white and familiar. But if you owned a telescope or even a decent pair of binoculars, you might notice something small. The moon would look slightly larger than it did last week. Not enough to alarm you, not enough to make the news, just enough that you might squint and think, that seems closer. Within a week, the tides would begin to change. You might live nowhere near the ocean. You might never think about tides at all. But the moon controls the ocean the way a magnet controls iron filings. Its gravity pulls water toward it in a great bulge, twice a day, every day, all around the planet. Right now, the moon is about 239,000 miles away, and even at that distance, it raises and lowers the ocean by several feet in most places, and by more than 50 feet in certain bays and inlets. The Bay of Fundy in Nova Scotia already sees tidal ranges of over 53 feet because of how the coastline funnels the moon's gravitational pull. Imagine what happens when that pull doubles, triples, when the moon is 10 times closer than it is now. The coastline, would begin to disappear. Cities like Miami, Amsterdam, Shanghai, Mumbai, and Lagos, places already barely above sea level, would start to flood. Not in a gentle, rising tide way. In a violent, twice-a-day surge that eats entire neighborhoods. Every 12 hours, a wall of seawater would rush inland. Every 12 hours, it would pull back, dragging cars, soil, sewage, and the foundations of buildings with it. You would not be able to rebuild between floods. The water would come faster than you could drain it. But the tides would only be the beginning. The moon does not just pull on the ocean, it pulls on the ground beneath your feet. You have never felt this because the effect is tiny at the moon's current distance. But the Earth is not a solid, unyielding ball. It flexes. The crust bends slightly under the moon's gravity, the way a rubber ball dents when you press your thumb into it. Scientists call this Earth tide, and it happens invisibly, twice a day, right now, under every city, every mountain, every field on the planet. You do not feel it because the movement is less than a foot. But as the moon closed in, the flexing would intensify. The ground would start to rise and fall by feet, then by dozens of feet, twice a day. Imagine standing in your kitchen and feeling the floor push upward beneath you, gently at first, then violently, like the breathing of something enormous and alive. Fault lines would begin to slip. Earthquakes that have been building pressure for centuries would release all at once. The ring of fire, the horseshoe of volcanic and seismic activity around the Pacific Ocean, would erupt. Not metaphorically, literally. Magma that has been sitting miles underground for thousands of years would find new paths to the surface as the crust cracked and shifted. In 1975, planetary scientists William Hartmann and Donald Davis proposed what is now called the giant impact hypothesis. They argued that the moon itself was born from a collision. 4.5 billion years ago, a Mars-sized body called Theia slammed into the young Earth. The impact was so violent that it vaporized rock, sent a disk of debris into orbit, and that debris eventually cooled and clumped together into the moon we see tonight. The Apollo missions brought back lunar rocks that confirmed this. The oxygen isotopes in moon rocks are almost identical to those in Earth's mantle, meaning the moon is literally made of Earth. It was born from a wound. That first collision nearly destroyed the planet. It turned Earth's surface into a sea of magma hundreds of miles deep. If the moon came back, the reunion would be no gentler. As it spiraled closer, the moon would cross a boundary called the Roche limit. This is the distance at which a celestial body held together by its own gravity gets torn apart by the gravity of the larger body it is approaching. For the moon and Earth, the Roche limit is about 11,400 miles from Earth's center. At that distance, the tidal forces stretching the moon would exceed the gravity holding it together. The moon would begin to crack, first in small fissures across its surface, then in massive fractures that split entire regions. Rock and dust would begin to break free and spiral outward, forming a ring of debris around Earth. not the elegant, icy rings of Saturn, but a violent, grinding belt of rock and dust that would shadow the entire planet. Pieces of the moon would begin to fall. Not one asteroid, not a single extinction-level impact. Thousands of impacts, millions. Moon rocks ranging from pebbles to mountains would rain down on Earth's surface in a bombardment that would make the worst volcanic eruption in history look like a candle. Each impact would throw more dust and debris into the atmosphere. The sky would go dark, not nighttime dark, permanent dark. The kind of dark where you cannot see your hand in front of your face at noon. Sunlight would be blocked by a thick shroud of pulverized rock and vaporized metal. NASA's Grail mission, which flew twin spacecraft around the moon between 2011 and 2012, mapped the moon's interior in unprecedented detail. It found that the moon's crust is cracked and porous, riddled with the scars of billions of years of impacts. If that already fractured body entered the Roche limit, it would not hold together. It would shatter like a porcelain plate dropped on concrete. And if somehow, impossibly, the moon held together and actually struck Earth, the collision would be beyond anything language can describe. The energy released would vaporize the crust on the impact side instantly. A shockwave would race through the planet's mantle, liquefying rock everywhere. The oceans on the far side of the Earth would boil, not slowly, not in patches, but all at once, as the heat from the impact radiated through the entire planet. The atmosphere would be blown off into space. The surface would become a second magma ocean, just like after the Theia impact 4.5 billion years ago. There would be no survivors, not humans, not animals, not plants, not bacteria on the surface. The Earth would be sterilized, reset to a state it has not been in since it was an infant planet with no name and no life. But here is what you will not expect. This has already happened, not to Earth but nearby. In 1994, the comet Shoemaker-Levy 9, discovered by astronomers Carolyn and Eugene Shoemaker along with David Levy, broke apart after passing Jupiter's Roche limit. It shattered into more than 20 fragments, each up to 2 kilometers wide. Over the course of a week in July 1994, those fragments slammed into Jupiter one by one. The largest impact left a scar on Jupiter's atmosphere bigger than Earth itself. Astronomers around the world watched it happen in real time through their telescopes. It was the first time humans had ever witnessed a collision between two solar system bodies. Jupiter, a gas giant with no solid surface, absorbed the blows and healed. Earth would not be so lucky. Now pull back from the catastrophe. Pull all the way back to tonight. Look up. The moon is there, 239,000 miles away, doing exactly what it has done for 4.5 billion years. It is not falling. It is not spiraling inward. It is drifting outward, 1.5 inches per year, pulling the tides gently, flexing the crust invisibly, lighting your night sky with reflected sunlight. And you have barely noticed. The moon stabilizes Earth's tilt. Without it, Earth's axis would wobble chaotically, swinging between 0 and 85 degrees over thousands of years. That wobble would turn seasons into chaos. Winters could last decades. Equatorial regions could become poles. The stable, predictable climate that allowed agriculture, civilization, cities, and everything you know would not exist. The moon is not just a pretty light in the sky. It is the reason your world makes sense. So tonight, when you step outside, see that white disk above you, remember this. It is a piece of the Earth that was torn away before life even existed. It is the scar of the most violent thing that has ever happened to this planet. And it is the only reason you are here at all. The moon is not falling toward you. But if it ever did, you would not survive long enough to look up and see it coming. The next time someone asks you why the moon matters, tell them this. It is not hanging above you. It is holding you together.